Hi, thanks and welcome for joining for this optional video. Just got 5 slides of examples that we need to get through here. So find the equation of an ellipse in standard form. Now, the important thing about the standard form of an ellipse is that there is no coefficient of the x squared or y squared terms. Additionally, in an ellipse, you always have it equal to 1. That is a non-changing thing. So what we're going to first deal with is the equal to 36, and that sort of takes care of the other issues sometimes. So because this needs to be equal to 1, what I'm going to do is divide by 36. And when I do that, I'm dividing by the 36 everywhere. And then all I'm going to be doing is reducing all of these fractions. So 4 36ths is just going to be giving me 1/9, or x squared over 9. Plus 9 36ths is 1/4, so that's going to be giving me y squared over 4, and 36 over 36 obviously being 1. Now in this case, that takes care of the issue. X squared over 9 plus y squared over 4 is equal to 1, and that is in standard form now, so I'll leave it just like that. It's not asking for anything else, so I'm done. The next problem obviously takes a lot more work. So looking at this, I have 9x squared plus 4y squared minus 54x plus 40y plus 37 equals 0. So this is a case where I have the x squared, but I also have an x term, and that immediately alerts me that I'm going to have to complete the square. So I'm going to have 9x squared minus 54x, and then I'm also going to group together my y squareds. So I'll say I have plus 4y squared plus 40y, and I'm going to move my 37 to the other side, equals negative 37. And now I'm going to complete the square with my x's and with my y's separately. The first step in completing the square there is I need to factor out whatever that lead coefficient is. So I'm going to have 9 x squared minus 6x plus blank. Now half of negative 6 is negative 3, squared is a positive 9. But keep in mind that you didn't just throw in a 9 into this equation. You really threw in a 9 times 9. So you threw in 81, which means I need to balance this by adding in 81. Next, looking at my y squareds, I can factor a 4 out, and I'm left with y squared plus 10y plus half of 10 is 5, squared is 25. And again, here I didn't just throw in a 25. I threw in a 100 because it's a 4 times 25. So I have to balance that by adding in that 100. So here I'll have 9 times x minus 3 squared plus 4 times y plus 5 squared is equal to 181 minus 37, which gives me 144. Now I'm almost in standard form. I have to have this equal to 1 in order for it to be an ellipse. So I'm going to divide by the 144 to all three of my terms. 9 144ths is going to give me a 16th, so I'll have x minus 3 squared over 16, plus 4 over 144 is a 38th, so I'll have y plus 5 squared over 38 is equal to, again, 1. So there we have two cases in which what we had to do was sort of put this into standard form before we would then be able to do any identification of like the foci or foci, that game, center, vertices, and so on and so forth. Next, find the standard form of the equation of the major ellipse with foci, that word, with focal points. There we go. With focal points at 0, 3, and 0, negative 3, and a major axis of length 10. So what just like with parabolas, what I like to do is sometimes give myself a little idea of what this sort of looks like. So I'm at 0, 3, and 0, negative 3 are my focal points. Now, the midpoint of those focal points is right here, 0, 0, which must be my center. So I know that my center is 0, 0. Next, the major axis has a length of 10. So the major axis having a length of 10 means that the entire major axis is length 10. Since that gets split equally, that means I must be going up 5 and down 5. So right here, what this is telling me is A is equal to 5. So again, you sort of look here, and you have two of your vertices. And then here you have your center. I do know that that major axis is a vertical one, again, because the focal points have to lie on it. So the other thing I'm going to need, or let's try and put in what we do know so far. Because this, well, let's start with the regular equation. X minus h squared plus y minus k squared equals 1. And then what you usually have here is a squared, b squared, and that's where it sort of floats around in between those. Because the major axis is vertical, this is my a squared, this is my b squared. So what things do we know? Well, we know h, we know k, we know a, and what we also know is c. We know that c is equal to 3 because c represents the focal length. And what we need to remember is that for an ellipse, a squared minus b squared is equal to c squared. So you have almost a Pythagorean theorem here. So we're going to have 25 minus b squared equals 9, substituting in our 5 and our 3. So b squared is equal to 16, so b is equal to 4. And now I have everything I need to substitute in. I have h, k, a, and b. So I'm going to have x squared over b squared, which is 16, plus y squared over a squared, which is 25, equals 1. And again, keeping in mind, in this case, the center was 0, 0, so I didn't have any part of that binomial. All right, another example of that. Find the standard form for an equation of an ellipse with vertices at 0 plus or minus 8 and focal points at 0 plus or minus 4. So again, just to give myself an idea, here I have 0 plus or minus 8 as my vertices and 0 plus or minus 4 as my focal points. The center has to be the midpoint of that. So I know my center is again at 0, 0. I know that this is an ellipse that's sort of vertical. So I know that my a must be underneath the y squared term, or my a squared must be equal or under the y squared term. Looking at this, the focal length, c, is equal to 4 because I'm going either up 4 or down 4. And the a value must be equal to 8 because I'm going either up 8 or down 8. You do have to be careful about which vertices they give. It was possible that they would have given two of these horizontal vertices. Typically, it's a little bit sketchy. Sometimes vertices they consider just to be your major vertices. But I could give you these two as well, which means I'm really giving you the b value. So again, I have to do the Pythagorean theorem to solve for what b is. So remember that a squared minus b squared equals c squared. So 64 minus b squared is equal to 16. So b squared is equal to 48. Now I could square root this and solve what b is, but keep in mind that in the formula, what I need to know is what a squared is and what b squared is. So yes, I can square root this all I want, but I don't actually need that if all I'm trying to do is write the equation. I would need it in order to graph the function, or graph the ellipse, but I don't need it in order to write the equation. So center, x, minus 0 squared plus y minus 0 squared equals 1. Because this is opening sort of height-wise, my a squared, which is 64, must be underneath the y. And my b squared, which is 48, must be underneath the x. And again, that's sort of why I don't actually care what square root 48 is, although it would be helpful if I were graphing. All right, find the standard form for an equation of an ellipse with focal points at plus or minus 2 and a major axis of length 6. So my focal points are at plus or minus 2, 0. That means that my center must again be at 0, 0, because it has to be the midpoint of those. And then it also tells me that the major axis has a length of 6. So it's giving me the length of the entire major axis, which must be the horizontal in this case, because the focal points must lie on the major axis. And since this is starting at 0, it must be going to 3 and negative 3. So I have my center, my vertices, and my focal points. Looking at this, my focal length, which is c, is 2. My a value, which is the length from the center to the vertex, sort of a major vertex, is 3. So again, doing that sort of Pythagorean theorem, a squared minus b squared equals c squared. I'll have 9 minus b squared is equal to 4. So b squared equals 5. So I always start this off just doing the numerators. Our center, we said, is 0, 0. So I'll have x minus 0 squared plus y minus 0 squared equals 1. And then underneath here, because this is opening sort of, well, not opening, because it's laying horizontally, it's more ovally horizontally, that means that your a squared must be underneath x. So a squared is 9 underneath the x. B squared is 5 underneath the y. All right, and then last, find the equation of ellipse in standard form with the vertices at 0, 0 and 0, 8. 0, 0 and 0, 8. Okay, 0, 0 and 0, 8 are our vertices, and it has a focal length of 2. So first thing, if these are my two vertices, then my center must be in the midpoint of them. So my center must be right here, and that center must be occurring at 0, 4. If this is 4, the focal length is 2, so I must be going from there up 2 and down 2 for my focal points. And that's telling me again c is equal to 2, because c is the focal length here. A, since the midpoint of these is 0, 4, I'm going up 4 or down 4, so a is equal to 4. Again, a squared minus b squared equals c squared. So 16 minus b squared is equal to 4. So b squared equals 12. And again, I'm going to start just with the numerators. So I have x minus 0 squared plus y minus 4 squared is equal to 1. And then because this major axis is vertical, my a squared needs to be underneath y. So a squared is 16 underneath the y. B squared is 12 underneath the x. All right, that's it. Pretty cut and dry, not super exhilarating. Very similar to what we did in section 9.1, where we had those other types of questions that weren't directly just graphing these. Now that covers most of the questions that you're going to face, so you should be able to finish up everything in that homework before moving on to the wonderful 9.3 hyperbolas.